So let me do a quick introduction. I'm Maciej Bajkowski. Next to me is Joel Crisp. We're from Bitfusion out of Austin, Texas. What we're going to be discussing today is a little bit about how we use Salt with Docker orchestration to solve some of our problems. If you can go to the next slide, Joel. So the agenda is I'm just going to give a quick overview why it is we decided to progress down this path and how that tied into our solution. And then Joel is going to go into the nitty-gritty and talk about how we actually implemented it, right? Next slide. So basically, what Bitfusion, what we do is, the problem we're trying to solve is this, right? A lot of people have data centers. A lot of people are trying to use some exotic architectures. They might be trying to use some FPGAs. They might be trying to use some GPUs and some other things like that, right? And usually those are fairly scarce resources. If you look at the data center today, most often when you get a server, you might get it with 2 GPUs, maybe 4 GPUs. If you're extremely lucky and you can supply a lot of power or other things, you might get one with 8 GPUs. But the fact is, most of the time you're gonna have a lot of generic purpose CPU boxes and only a few GPU boxes, right? Now, what do you do when you have an application that can take advantage of a lot of those boxes, but maybe it's not written in a way to be distributed, or it's not written to be containerized, to be distributed across many nodes, right? So that is where we step in, right? We essentially say, don't worry about it. We're gonna use Docker, we're gonna use containers, and we're gonna tie this all together with Salt, and we're gonna give you a virtual instance that to your application looks essentially like a single instance that your application is running on, right? So you as a programmer don't have to do anything special. You don't need to worry too much about Spark. You don't want to have to worry about MPI. You don't need to worry about a whole bunch of other things. As long as you write your things in CUDA, OpenCL, or whatever other GPU things, it should work for you, okay? So just a quick blurb about how we do it. On top, what you see there is essentially the application, right? What we interject is an intermediate layer, which we call Bitfusion Boost, right? Bitfusion Boost, essentially what it does, it intercepts calls that are usually targeted at a specific graphics card, right? So it can be CUDA or it can be OpenCL. There's a few other frameworks we're looking at. And it does a redirection, right? And we started out like, we can do this on one system, great. But then if you go to any board like maybe AWS or something like that, you realize, hey, there's only a 4 GPU system. What if I want to run across 20 GPU systems? So we talked to Joel and we told him, hey, you know what? We got to make this somehow portable. We want to be able to distribute across, I want to run with 32 GPUs. I want to run with 64 GPUs. And I want to make it really easy for people to be able to deploy this, right? And so this introduces a whole bunch of complications. We have servers that need to talk to each other, servers that need to talk to the master server, servers, and it all has to happen in a very async fashion, right? But that's what we do. But what we need Joel to solve is for us to bring this whole thing up, take our technology, distribute it, set up the networking, make it talk to each other, and basically that's where we go from there. So, and if this wasn't difficult enough, next slide. We told Joel, yeah, we would like to deploy just about anywhere. So the people that have a small data center with 20 machines, bare metal, sure, deploy it there. If they want to run it in the cloud, we want to deploy it there. We don't really care which cloud, it needs to deploy everywhere. And so with that, I hand it over to Joel to see how we solve the problem.
So thanks, Maciej. Can everybody hear me okay back there? Good. So as Maciej kind of introduced, the problem is how do we go beyond just installing Docker with Salt and actually do some more useful things with it. We looked at some of the other tool chains that we could use to do this with. Really, what we were looking for was a tool chain that would let us do VMs and Docker and mix them together. And we already had some Salt in the organization to deal with our VMs. We're also looking for a very tight integration with our existing environment as a result of that. So we looked at a whole bunch of Docker tools, and none of them really did what we wanted to do because they were all very Docker-centric and didn't really deal with VMs or other kinds of infrastructure like bare metal that we were interested in. And we looked at a whole bunch of VM tools, and they didn't really deal very well with Docker. So we looked around to find a tool that would do those things, and this is a big surprise to everybody here, I'm sure, we found Salt. And Salt really worked very well for us because we have a very deep integration with the VM environment, with Salt Cloud, that is also cross-provider, so that we can use it with, Amazon or Rackspace or any one of these other clouds that we wanted to deal with. And it has very good integration with Docker, with the Docker NG module. It's very good at environments where you have things coming and going a lot, which some of the other tools struggle a little bit with because they're very IP address sensitive. But with Salt, you can use minion keys that aren't particularly IP bound. So that gives you a much better tool for managing environments with very short-lived machines that come and go very rapidly. And the thing that we really started to find out we could do with Salt is use Reactor to give us a lot more interactivity and feedback loops for what we wanted to do. So what I'm going to show you in this presentation is a very small slice of what we have in our data center, focused around how we do some things with Docker and Salt. And obviously this has been rewritten for the demo, so some of the techniques I use in the demo we wouldn't necessarily use in a real data center. But we don't really have time to go through the whole thing here, so we had to cut it down quite a bit. So the SaltStack event system, if anybody was in the talk yesterday about this, allows you to trigger behaviors in Salt based on events coming from Salt minions. But we wanted to take that one stage further. Docker has an event stream, which is sourced using the server-side event protocol, which basically means it's opened up as an HTTP port, you connect to it with a persistent connection, and it pumps an event stream down to you. So we wanted to be able to take those events coming from Docker, we wanted to be able to feed them onto the Salt event bus, and then have Salt reactors track those events and carry out behaviors when we actually had an event come in. On here, obviously, I've got Slack as an example because everybody loves Slack these days. But we can do other things. We can change environments, so we can get an event come in that says there's a new container. We can trigger Salt. Salt can go and reconfigure the firewall to allow one of our customers access to that container. We can do push notifications to various things like Slack or any other system that you would want to interact with. We can do other things as well. I mean, with the Reactor, you can go and push out high states, you can go and do orchestration jobs. So there's an awful lot of really cool stuff that Reactor allows us to do. So before we actually did all of that, I'm just going to quickly go over our environment to tell you what we actually have. So we have Docker. We're running Overlay FS, for those of you who are familiar with Docker. For those who aren't, Docker has a number of different backends. It has a backend where it stores the files for all the containers in one huge file, but with Overlay FS, it's a little more flexible, a little faster. So we use SaltStack 2015-882 since that was released. We're using Docker 1.10.1 and Ubuntu 14.04 LTS because that's what a lot of our customers are interested in. We build our Amazon images with Packer and SaltStack Provisioner, which gives us a very repeatable way to generate an Amazon image, also using the same salt stakes that we will then use to manage that image for the rest of its life cycle. So another quick overview of the Salt Event Reactor. We have the Salt minion will trigger an event. That's caught by the Salt master, which uses pattern matching to decide whether or not to run a reactor. When the reactor runs, it triggers the notification to Slack. When we get the event response, we can do things like high state the minion or run an orchestrate job on the minion. So how many people here have actually used Reactor? So a couple of you, quite a lot not. So I'll just go over this quickly. For those of you who know this stuff, please bear with me while we look at this. But let's just take a quick look at what sort of things we might see coming through. Hold on a sec, sorry. So what I'm running on the right-hand window here is the salt command that will actually show me what activity is occurring on the salt message bus. And because there's a lot of that, we've restricted it just to events that have the keyword Bitfusion in the title. So I'm going to send an event now, and there we can see on the right-hand side that event has appeared. It's a block of JSON that we can see has the message, hello, saltcomp16, as part of the payload. So this is very important because we can send arbitrary payloads with the salt events. So, oops, sorry, just lost my cursor there for a second. So going back to the event system here, what I did on the left-hand side is this top message where we were, lost my pointer, hold on a sec. There we go. The salt call where we sent the message, the salt state event run. And you can see more details about this on the salt website, where they have a very nice example on auto-accepting salt keys. Now, the detail of the reactor is the next part on this slide, where you can see that, like most salt states, we have an identifier that tells us what the name of the reactor is, and then we have an event matching expression, which is simply a regular expression that matches the event tag. And that's really nice because you can have fuzzy matches in there with the regular expression syntax. And then when we actually catch an event, we have a salt state that we can run.
I think there was a question.
What was the point of mentioning the auto-accepting keys?
It's the example that's on the salt website.
Okay.
So,
as an event, gotcha.
as an example of how to use the reactor. Yeah. So this diagram I'm going to go over fairly quickly because this is actually on the Docker website, and as you can see it's fairly complicated, but this is the life cycle of a Docker container. So you can see that when Docker run is started or Docker create, the container will be spun up and it'll begin executing, and it will send you an event for both of those transitions, and pretty much all of the other transitions that you see here, Docker can send you an event for. So this is really powerful. You can say, I want to have salt respond if a Docker container dies unexpectedly. You can say when a new container comes up, I want to do something based around that new container coming up. So this is a really powerful model of the life cycle for Docker containers. And it is available on that URL on the Docker website. So this is what an actual Docker event looks like when it comes through from the SSE stream. Again, you can see not very nicely it's already JSON for us. It tells us what the particular transition was, in this case a pull. It tells us what the type of the actor is, in this case image. And we can see that in this example the image was the BusyBox latest image for Docker that was being pulled down. And then we have some timestamps just for general housekeeping. So what we're going to do is spin up some Docker containers and have Salt react to those containers coming up by making some changes in the global Salt state for us. So the way we do that is we have Docker running on a Docker host with a Salt minion on it. And what that will do is receive a request from Salt saying create a server container. We then get a Docker SSE event that comes back, and we use a small bridge written in the programming language Go, which will actually intercept that Docker event and republish it to the Salt master. Then the Salt master reactor runs, as we expect from the previous slide, and in this case, it runs an orchestration script that will go and update the list of available servers on the Salt minion and create the client on the Salt minion potentially, and then the client now knows it can connect to the server. So in my case, I'm going to just create the client manually for the demo purposes. And also, there are many different ways to solve this problem. In our case, we can either update a list of available servers, for example, as you would do in a load balancer, or what we can do is simply go and make another Salt call that will scrape the minion grain data and tell us that there is a Docker container running on that minion, or we can run docker ng and list the containers that are running on the minion. So there's many different ways that you can actually get this information back from your salt minions to your master. But the key point is you can trigger all of those behaviors by listening to the Docker event stream. So, sorry, go ahead.
Question about the Go bridge that you wrote.
Yes.
Can you give a reason for doing that? Like, is there another way to do it like in Salt natively?
You could easily do it in Python. We used Go because we had Go available. Go is a very nice language for doing quick and dirty things with JSON. It has very good JSON deserialization structures and so on.
I agree with you.
I'll actually show you the
like-
program in a minute, but definitely you could do it with Python just as easily.
Okay.
You know. So, how does all this work in practice? Well, let's see if we can do a quick demo now and demonstrate some of this stuff working. And this is a live demo, so please bear with me if there's any issues. So, going back to our machine here. So, what we're going to do first of all is take a look at a file which is in TMP, and as you can see, it's empty right now. And this is just representative of your load balancer configuration or other configuration like that. And as I say, I'm using a static file, but that's a really bad idea. I'm just doing that for the demo. You would normally do this in a more sane state. So let's actually run a container locally and see whether or not we have a GPU available to us. So we're going to run the CUDA device query command from the NVIDIA CUDA toolkit that allows us to basically probe for the GPUs available on the system and see if there are any GPUs available on the system. And as you can see, it's come back. We saw some events go pass through there. I'm going to close this window now because we don't need it anymore. And what we can see here is that CUDA found 0 servers.
This is kind of like the hello world of the CUDA programming language. It just goes in and queries your system, tells you, hey, I would like to use a GPU. You have CUDA toolkit installed, but do you have any GPUs? And what it showed in this case, sorry, nothing there.
So now what we're going to do is start a server. And, oh look, we got a notification from Slack down on the bottom right-hand corner of the screen there, saying that our reactor caught an event and sent a message to us on Slack telling us that we now have a new server available. So this is an example of actually that reactor triggering on an event and actually sending a message to Slack as a result of us starting that container. So now let's run our device query again. And we can see now that it's now found device 0, a grid K520 GPU. So what we've done, if we now look at our config file, is we've changed our config file with the salt state. So the salt reactor tracked that event, wrote the IP address of the minion on which we started that Docker container into this config file, and then our adapter could find the server and talk to the GPU.
So what's going on here is essentially we are on a system that does not have any GPUs to it. We have some other remote system that's running a Docker container that's talking to remote GPUs. But on the system without GPUs, we are able to execute a program, a GPU program, even though it's offloading all the GPU calculations remotely to a different server that has. So you can see how it allows us to start building very dynamic and flexible configuration. Our little client system could be a high memory box. Our GPU box could be just a dumb box, but with some very powerful GPUs, and we can slap them all together in a dynamic fashion like this and expose it directly to the user.
And that's really nice for our customers because the latest NVIDIA GPUs, the K80s, are really quite temperamental. They take a lot of power, they produce a lot of heat, they need custom chassis. So the fewer of those you can buy and maintain, and the better utilization you can get out of them, the more efficient it is for your company. So now that we've got this running, I'm going to stop the container that I started, and I'm actually just going to do that locally here. We're actually just running this one for demo purposes on this machine locally. So let me just do a docker stop, which is the name of the container with Docker's rather esoteric naming scheme. And this just takes a couple of seconds to go through as it goes and cleanly stops the container. Right. And there we see again our Slack notification telling us that the server is now stopped. And if we look at our config file, it's now empty again. So this is showing you the teardown process where you could go and change your load balancer or whatever, or shut your firewall hole when the container goes away again. So I'm going to show you now the same thing, but really with remote servers. So this is where things get fun with the demo. So I'm now going to start a bunch of servers. And what we're doing here is we're running now a salt command, which is using the salt grain selectors to pick up a bunch of salt minions that have Bitfusion role server. And on those servers, we are starting a Docker container. And those of you who are watching closely will have seen it flashing up the Slack notifications. And we can now see again that we now have these 4 servers have all started from that one salt command. So you could also do this with the Docker ng module. The only reason why I didn't do that is we're actually using NVIDIA's extensions to Docker, which are not yet supported by Docker ng. But if you were using normal Docker containers, then you could just go and use the Docker ng module, and you can then use state modules and salt states all seamlessly with Docker using that Docker ng. However, we're using NVIDIA Docker for these particular systems, so we actually had to send the command line to them instead. But that's another fun thing you can do with Salt, is this highly capable selection of machines based on grains, and then running the command lines on them.
Sorry, one question. Are you using grains or are you using salt line?
We are actually using grains on this because we found that it's often more reliable for us to statically configure the grains on our system for their particular role, and then dynamically query the system once we know what the role is. Salt mine we found occasionally hasn't worked as well.
Okay. So you're going into each of the minions and pulling them for the information you need?
Yes, that's one way to do this. As I said, there's several different ways to do it, and you can maintain state in salt mine, or you can maintain state in updated grains, or you can call out to other applications for doing that. So the next thing we're going to do, obviously, then, is actually let's launch that same command again, and this time we're doing that call to look up the grains, just for variety, rather than using the static config file. And as you can see here now, our local Docker container can now see 16 GPUs on 4 each on those 4 remote servers. So this is a very powerful tool for us with Salt to be able to go out, manipulate our Docker ecosystem, and bring up these particular machines based on the various roles. We can use grain metadata to tag different customers, so that we can bring up servers for specific customers. We can bring up servers on specific types of hardware. We can do a lot of other things like that. So let's just have a quick look at some of the actual logic behind this. And as I mentioned earlier, we have this little Go program. It's literally very short. We have a few imports at the top, standard Go boilerplate. We have the type of event that Docker will send to us as a Go structure. And this is very nice because Go lets us demarshal JSON very easily into this nice structural format where it's a lot easier to manipulate because the compiler will do all your type checking and so on. Then we have just a very simple little loop here where we're opening up an HTTP connection to the Docker web server. We're connecting to the SSE event stream from this, and we're pulling each event in turn. We decode it using the JSON demarshaller, and then we do a couple of sanity checks. and recode it actually so that we can send it to Salt. But what we basically do is a very simple call to the Salt call. And obviously, if you were using Python, you could use the Python intrinsics for Salt. You could also use the Salt API if you wanted to do this remotely and talk to Salt over HTTP instead of using Salt call. It actually works pretty well using Salt call. Salt call is a pretty fast call, and it just pushes the event onto the event bus and sends it to the master. So the things that we're sending as arguments to this is basically the tag for the event, which is what is used by the reactor matching, which is basically Bitfusion Docker, the event ID, the event, and the event status, such as start, stop, and so on. And we have the event detail that we are sending as well, which is basically actually that entire JSON block that Docker sent to us. So we have all of the information available in our Salt reactor to pull that apart. And then we just, have a little bit more sanity checking and just loop back again. And it really is that simple. That's all you need to do to be able to integrate the Docker event stream directly onto the Salt event bus. So then the two commands we were running earlier, the device query command, we're doing a standard Docker run, but we're mapping our external file into Docker. So this is the file that was being maintained by our reactors when an event comes in, and we're basically just replacing the file in the Docker container with the external one. As I say, that's not the best way to do this, but that's expedient for the demo. And then we just run the various Docker container with the actual command that we need. And then the server, the same thing, we're running NVIDIA Docker, not very interesting, that one. But let's go and look at some of the actual reactor scripts now in here. And we have our standard tree with our salt states in here. So within here, we have the orchestration adapter conf, and this is what runs in response to the reactor. So we basically pull out our server ID, we append it onto a grain, and then we write the contents of that grain into the config file. So this is just a very sloppy example as to how you might update that firewall config or that load balancer config. So triggering all of that, we do out of the reactors. And this is what an actual reactor looks like to trigger that behavior. So here we can see that we're using the data that we sent, which is the entire event from Docker, and we're able to walk down through the various dictionaries in that event and confirm that the event that we saw was really one we're interested in. So at this point, using the Ginger templating in Salt, we're going to ignore events that come through that are not specifically for that particular image. So you can have several one of these to behave with different Docker images in different ways, or you can write the image ID into your tag and use the reactor regular expression matching. So then we do our rather nice little Slack post, and for those of you who are security aware, that's not a real key, so don't try to use it. And then having done the Slack post, we then call that orchestration module that I showed you earlier to update the state on the rest of our system. So in order for this to trigger, we actually need some system configuration on Salt. And so what we actually have here as well is we have in the master configuration directory, because all of the reactors run on the master. So all of the events that you need to catch are caught by the Salt master. We have our reactor config here. And as you can see, this is a very simple file. What we essentially have is that auth example that I mentioned earlier that's on the Salt website. And by the way, that's a great place to get started with reactors, because when you have a new minion come up, the reactor causes the master to auto-accept the minion key. So if you have a highly dynamic environment where you're starting lots and lots of Salt servers, you really want to have something like that so you don't have to keep on accepting keys manually or using a single shared key for all of your minions. So that's a very nice example of, you know, how to intelligently automate your data center with reactors. And then we have our Salt minion start, which is the second half of the authentication, so that we get the pending auth and then we complete the authentication process. And then we have our new one, which is the Docker event create. So we're saying when a new Docker container is created, and we see that event, run the Docker create salt state, which is that reactor orchestration script that we saw earlier that actually goes and carries out the event capture and then the propagation of that state to the other systems. So that concludes this portion of the demo. I don't know, we have some time for questions. If I can find my slides again. There we go. That's it? Has it gone away? There we go. No. Hold on. There we go. Sorry, I'm not very familiar with PowerPoint. I don't use Windows very often, but there we go. Okay. So if anybody has any questions now, okay, go ahead.
Will you open source the code just or
Do what?
is that secret sauce?
Will we open source the
Just the demo portion.
demo portion of the code?
I think the demo portion, yeah. I think we'll
Yeah.
publish that.
So
Because our technology really is the automatic offloading of the CUDA and OpenCL. That's really our secret sauce. This is what we build the orchestration on top. As you can imagine, a lot of different people have, let's say you have a lot of people in your company and some people have a request for say 4 GPUs and other things have 12, 16 or 20 GPUs and we have a whole data center of these things going on. So this allows us to essentially orchestrate those different containers automatically, but the secret sauce is really the distribution and interception of the CUDA calls and OpenCL calls. So yeah, I don't see any problem with open sourcing that.
yeah,
This is a really good example. It's really clear
okay,
what you guys are doing here.
thank you.
It actually has made a lot of the talks that I've heard over the last 2 days a lot more clear.
Okay,
Yeah, so
go ahead.
actually, I meant to mention this at the start of the talk. There was a talk on actually how to install Docker with Salt. So for those of you who missed that, there is actually a Salt formula for installing Docker, which is actually what we use. It's very easy to use, very efficient, very nice to use. And then there was another talk on how to build Docker containers with Salt. And there was another talk on actually using Reactor for orchestration. So if you missed any of those talks, they should be on the Salt conference website, and you should be able to watch the videos for them after this. So if you find that you look at this talk again and you can't remember what it was I was doing, you know, please go and have a look at those talks, and they should help you with that.
Yeah, also for those of you thinking about exploring GPUs, NVIDIA has made quite a few strides in making Docker easier to use with GPUs than it used to be. Let's put it that way. So that you should. That's why when Joel was talking about it, we're using their NVIDIA wrapper for Docker, just because it makes a lot of the device pass-through and other things that you need to do to get the GPUs to be shareable amongst containers much easier.
Yeah. So we'll put a link up to that presentation source code on our Bitfusion.io website. So give us a day, because we've got to fly back today and set a couple of things up. But by Monday, we should have a link up on there to this stuff, and you should be able to go and find all the source code on Bitfusion.io. So I think there are a couple of other questions. The gentleman there.
For that Go service that you're running, is that just a service on the minion that's hosting the Docker containers?
Yeah, so the question there was the Go service that we're running, is it running on the Minion? It is. It's just an upstart service that runs on the Minion. It's very trivial. If it drops the connection to Docker at all, it just exits and upstart restarts it, and it'll try to reconnect then. So it runs on the Minion, and we actually have a high state that pushes it out and ensures that it's running. So that actually is also managed by Salt. So the gentleman there?
You said that you created your Docker event stream using your Go application. I did look inside of the engine stream directory, that would be the current development branch of Salt. There is a Docker event engine, although I don't know if it works, and I don't know if it's currently released.
So the statement there was that they're in the current development branch of Salt, which is the Here Be Dragons version. There is actually a Docker event connector. So that may well answer the earlier question is, can you do this natively in Salt?
Well, it was more that, like, did it exist at the time? Was there a good reason that you used it?
Yeah.
Sounds like it wasn't, so.
Yes.
So that made more sense.
So it sounds as if it's definitely something that is worth looking into. I don't know exactly what the capabilities of that are, but if so, it would be a very nice addition because it would mean that we would not need to have the extra service running. So thank you for that. Does anybody have any more questions? Okay, well, thank you all. And as I say, you know, all of the information about this will be on our website, along with all the information about the BitFusion product, the GPU remoting features that we have, and another product that we have that will let you, built on top of all the stuff you've just seen, update a Docker container and run it on a wide variety of different machine types in Amazon and find out which one is most suited to your workload. So that we have a number of things there. Yeah, well, Maciej, did you want to add anything at this point?
I think you covered it all about, so I'm good.
Okay. Well, thank you very much.
Thank you guys, much appreciated.
Thank you.